Today we shall look at the quotient rule as another method of differentiation. And the quotient rule states that if y is equal to u over v, where u and v are both functions of x, that is, u is equal to u of x and v is equal to v of x, then the y dx is equal to v du dx minus u dv dx all over v squared. So this is the quotient rule of differentiation and is always used to find the differential coefficients of functions involving quotients. Alright, now let's look at few examples to have a deeper understanding of what we are talking about. Question number 1 says, if y is equal to e raised to power x over x squared, find dy dx. Okay. Now, in problems involving quotients, what we are going to do is to let u to be equal to the numerator and let v to be equal to the denominator. So, in doing that, we have let u is equal to e raised to power x and v equal to x squared. When we differentiate u with respect to x, du dx is equal to, we know that this function does not change. No matter the number of times you differentiate it, is always the same. And dv dx is equal to 2x. Alright. Now, but dy dx is equal to v du dx minus u dv dx all over v squared. So we now put the values there. This is equal to v is x squared multiplied by du dx is e to the x minus u is e raised to power x multiplied by dv dx is 2x, then divided by v squared, and our v is x squared, so we have x squared all raised to power 2. That's what we are going to have there. Okay, now if we continue, x squared times e raised to power x will give us x squared e raised to power x minus e raised to power x times 2x will give us 2x e raised to power x, then divided by, then we have x squared raised to power 2. According to the rule of indices, the powers will multiply each other. So we are going to have x raised to power 2 times 2 will give us 4. Okay. Now, we know that in this expression, x is common. E raised to power x is also common. So we factor out the common terms. So we're going to have x e raised to power x into, what remains here now is x minus, and what remains here is 2, divided by x raised to power 4. Because when we use this to multiply everything inside the bracket, we are still going to get back this. And finally, dy dx is equal to, now this x here, we cancel one of the x here. So what is left here now is x raised to power 3. So our result now is e raised to power x into x minus 2 divided by x raised to power 3. And that is the differential coefficient of e raised to power x over x squared. Okay, let's look at example number 2. Example number 2 says, if y is equal to ln x over x, find dy dx. Alright. Now we now say let u to be equal to the numerator, that is ln x, and v to be equal to the denominator, which is x. So when we differentiate, du dx is equal to the differential coefficient of ln x is 1 over x, and the differential coefficient of x is equal to 1. That is, dv dx is equal to 1. Alright, so when we combine all these parameters, dy dx is equal to v du dx minus u dv dx all over v squared. And this is equal to v is x, put x there, multiplied by du dx is 1 over x, then minus u is ln x, multiplied by dv dx is equal to 1, then divided by v squared, and our v is x, so we have x squared. Okay, so in this expression now, it is very clear that this x here, we cancel this x. So what is left here now is a 1. So dy dx is equal to 1 minus ln x times 1 will give us ln x divided by x squared. And that is the differential coefficient of ln x over x. We take example 3. Example 3 says, if y is equal to x squared divided by 1 plus x squared, find dy dx at x equal to 1. Okay, so as usual, we now say let u be x raised to power 2, that is this, and v be 1 plus x squared. Okay, now du dx is equal to 2x, and dv dx here is equal to the differential coefficient of 1 is equal to 0 because it's a constant. Then the differential coefficient of x squared is 2x. So when we combine the parameters together, but we know that dy dx is equal to v du dx minus u dv dx all over v squared, and this is equal to v is 1 plus x squared, that is 1 plus x squared, multiplied by du dx is 2x minus u is x squared multiplied by dv dx is 2x. Then divided by v squared, and v here is 1 plus x squared all squared. Okay. Now here we're going to use this 2x to multiply everything inside the bracket. Now 2x times 1 will give us, so dy dx is equal to 2x times 1 will give us 2x. 2x times x raised to power 2 will give us 2x raised to power 3 plus 2x raised to power 3, then minus x squared times 2x will give us 2x raised to power 3, then divided by 1 plus x squared all squared. So now 2x raised to power 3 minus 2x raised to power 3 is equal to 0. So dy dx is equal to 2x divided by 1 plus x squared all squared. So now remember we are asked to find dy dx at x is equal to 1. So at x is equal to 1, comma, dy dx is now equal to, anywhere we see x here we put 1. So it becomes 2 multiplied by 1 divided by 1 plus 1 squared all raised to power 2. And this will give us 2 times 1 is 2 divided by 1 plus 1 squared. 1 squared is 1. 1 plus 1 is 2. 2 raised to power 2 is equal to 4. And 2 divided by 4 is equal to 1 divided by 2. And that is the result. That is the answer to that very problem. Alright, let's look at another question. Maybe number 4. It says if y is equal to an x, find dy dx. Okay. Now we now say, of course, if you look at this problem, it says y is equal to tan x. It may seem to suggest that this problem is not a quotient function, but with our knowledge of trigonometry, we are going to translate tan x to look like a quotient function, because in trigonometry we know that tan x is equal to sine x over cos x. So that means that this function now is y is equal to sine x over cos x, because sine x over cos x is equal to tan x. Alright, so it's now a quotient function, and we can now say let u equal to sine x and v equal to cos x. Now du dx is equal to the differential coefficient of sine x is cos x, and the differential coefficient of cos x is equal to minus sine x. Alright, so now we now combine the parameters together, but we know that dy dx is equal to v du dx minus u dv dx all over v squared. Okay, now dy dx is equal to v is cos x multiplied by du dx is cos x minus u is sin x multiplied by dv dx is minus sin x divided by v squared, and our v is cos x, so what we are going to have is a cos squared x. Okay, now this is equal to cos x times cos x will give us cos squared x, then minus sin x times minus sin x will give us plus sin squared x divided by cos squared x. Now in trigonometry we know that cos squared x plus sin squared x is equal to 1. It's one of the parameters in trigonometry that we should know. Okay, and this is equal to, so since the whole of this is equal to 1, we replace this with 1, so it becomes 1 divided by cos squared x. And 1 over cos squared x in trigonometry is equal to sec squared x. So that means that the differential coefficient of tan x is equal to sec squared x. Then finally, let's look at this problem. It says if y is equal to sec x, find dy dx. If y is equal to sec x, find dy dx. Okay, now from trigonometry we can also translate sec x to look like a quotient function. Sec x is equal to 1 over cos x in trigonometry. So that means that this function now is a y is equal to 1 over cos x. So this is a quotient function now. Now we now say that let u equal to 1 and v equal to cos x. Then du dx is equal to, the differential coefficient of 1 is equal to 0, and dv dx of cos x is equal to minus sin x. Okay, but we know that dy dx is equal to v du dx minus u dv dx all over v squared. All right. Now, dy dx is equal to v is cos x multiplied by du dx is 0 minus u is 1 multiplied by dv dx is minus sin x, then divided by v is cos x, so we're going to square it, cos squared x. So this is equal to, now 0 times cos x will give us a 0, so everything here now translates to 0. Now minus 1 times minus sin x will give us sin x divided by cos squared x. All right, now this very expression can be written this way. It can be written as 1 over cos x multiplied by sin x over cos x, because 1 times sine x will give us sine x, and cos x times cos x will give us cos squared x. We just want to establish something. Now, this is equal to, we know that from trigonometry, 1 over cos x is sec x multiplied by, and sine x over cos x is tan x. So sec x times tan x will give us sec x tan x. So the differential coefficient of sec x is equal to sec x tan x. Thank you very much for your audience.